Hello, so today continuing on Leetcode daily problems to continue our streak of day 8 in April. So clone graph. What this problem says is we get a reference to a node in a connected undirected graph. So what we mean by undirected here is that, let's say we have node 1, right? And then we have node 2. So we have an edge between them. That basically means 2 is a neighbor of 1 and 1 is a neighbor of 2, right? And we want to create a deep copy of the graph, a deep clone or a copy. And each node has a value in the list of neighbors. So just normal graph. And just to clarify what they mean by clone here, we have this image. So the first image says that with the different colors says that the nodes are different. So we need to create actually a new node. For example, for 1, we need to create a new node. It should have the same value, but it should be a new different node with a different reference, right? So that's what this basically means. It's not this. We shouldn't keep the same nodes reference. And then this second one means that we should maintain the same neighbor relationship. So for example, here 1 shouldn't point to 3 because in this graph 1 is not pointing to 3. And so we need to have this to maintain the relationship. So here 1 is a neighbor of 2, 2 is a neighbor of 1, so we need to maintain the same thing. So that's the idea. Now in the constraint here we can see that the node values are unique, right? So if we need to use some sort of key or some sort of identifier, we can use the node values. And we shouldn't have any repeated edges and no solve loops, right? And the graph is all connected, right? So we don't need to worry about having different connected components, right? So that's the idea. Now let's see how we can solve it. Okay, so let's see how we can handle it for this example. So the first thing we want to do, of course, is create a copy, right? So let's say we start at the initial node. So one thing actually to mention about the problem is we get a node that is, because the graph is all connected, we just need to get one node, and from that node we can obtain all the nodes or the other nodes, right? And so what the problem says is if we get the initial node pointing to 1, when we return the deep copy, it needs to be pointing to that node, okay? And so what this means basically is that first we'll create a copy of the node. And so to create a copy, you can just, let's say, call it clone or copy maybe. And that copy will just need to be the same value but a new reference. So we can just create a new node and give it the same value as our initial node. So that node.val, okay? Now, one thing, the key point in this problem is that, so 2, for example, right? 1.neighbors contains 2, right? Okay, so this has 2 and 4, right? And then the other thing is that if we take also the other node, which is 3.neighbors also contains 2, right? So 2 and 4. And so what this tells you already is that if each time we hear a neighbor, we create a new node, we'll have duplicates nodes for 2, for example, and for 4, right? And so how do we avoid recreating a node that we already created? So when we start with 1, we'll traverse to 2, and then when we get to 3, how do we avoid creating 2 again? That's the key point of this solution. And so to do that, well, the solution to avoid recreating is just to store it, right? And so we just need a map. We can call it scene, we can call it a memoization, you can call it whatever you want. I'll call it scene. And then what should be the key and what should be the value? That's where one of the constraints that we had that said that the node values are unique means that here we can use as a key node.val because the problem says it's unique. If it wasn't unique, we'll have to figure out another solution. For example, in Python, we could use an ID, we could use a hash. But for this problem, the node value is unique, so let's just use that. And then what should be the value? Well, it's just the node itself, because what we'll do is first, when we start to 1 and explore its neighbors to copy them, we'll copy 2, right? And then when we get to 3, its neighbor is 2, so we'll check if there is already a copy. And we'll find that there is a copy, so we'll just make that the neighbor. So that's the main idea here. And so the way we'll do this then is we'll start out, we'll create a copy. So that copy would be 1. And then we will go through the neighbors. So first we'll start with 2. It doesn't exist yet, so let's create it. And let's make it a neighbor of 1. So basically just add it to the list of neighbors of 1. And then do the same thing for 4. So and then DFS, DFS on the neighbors, right? Because for each one, we want to both clone it and we want to create its neighbors. So actually with DFS, what will happen is we will first go all the way down with 2. So what are the neighbors of 2? We have 3, so we'll clone 3 and we'll put it as neighbor. And then with DFS, we'll go to 3, right? And then neighbors of 3, 4, so we created, right? And now what should happen? So actually this one, the direction for now is just like this. And now we will get to 4. For its neighbor initially here is 1, and so we'll check, is 1 in scene? It is, and so let's just put the link to the existing clone, and so we'll just do that like this. And then we get to, we finished our DFS here, and now we'll pull back 1. What is the neighbor of 1? It's 4, and so we'll create the neighbor for, we'll check 4 already exists, so we'll just create the link, which basically means adding to the list of neighbors of 1, adding 4. Similarly, so once we do that, we'll recurse on 4. What are the neighbors initially? 3. 3 already exists, and so we'll just create the link, and then we'll recurse on 3. 3, what are the neighbors? 2, and so we'll link, and then we'll link here. And now they are undirected. By link here, I mean just adding it to the list of neighbors. Right, and then at the end we'll have undirected, and we'll have all the nodes, right? So what we are doing here basically is just DFS, right? And we clone each node, and we maintain that we don't create multiple clones by using this map, okay? So that's the idea. Now in terms of time complexity, we are using DFS, and so DFS is usually O of E plus V. And the problem says we don't have any repeated edges, and we don't have any solve loops, right? So that tells you that we have n nodes, so that tells you that at most we'll have n plus 1 edges, and so overall it's O of 2n, so overall it's O of 1n time. In terms of space, it's also O of n, because we are creating a new graph that has the same nodes and edges, so we have also O of n space. And that's pretty much it for this problem. Now let's code it up and make sure it passes. Okay, so let's implement this solution. So what we need first is we need to define a clone for a node. So this is basically our DFS function, and we need to call it and return it, right? So in the end, we want to return it for the clone of this node. Okay, so now what should we do? So first we said if the node already, we need our scene map, right? So we need a map that has basically the keys node val and then the values as nodes. Okay, so here we need to check if it already exists in our scene map. If it does, no need to copy it again, we can just return it. Okay. Now, after that, remember we go through the neighbors. So for the neighbors of the node, we want to copy each one of them. And if it doesn't exist, the function call will just return if it exists already, the function call will just return the node that exists, right? And so here we actually just need to add to the node neighbors. And so let's first create, so when we get here, that means the node doesn't exist yet, so we need to create a clone for it. And we want to add it to our map so that next time we don't copy it again, right? And so here for this node that we registered here, we just want to add to its neighbors the clone of this neighbor. So how to get the clone? We just call the function recursively on the clone. And the good thing is if it exists already, we'll just get it right away. If it doesn't exist, we'll clone the node. And then at the end, we just want to return that node, right? Okay, and that should be it. The only remaining edge case that we need to handle is that what if the node, even the initial node that we get here, is none. It's empty, right? Empty graph. So we just need to handle that case because there will be no val for it, and so we just need to check if not node, we can return none. right? The other way of doing it is just to do if node, otherwise return none, right? And that should be it. So if we run this, this is neighbors. Sorry about that. Did I write it wrong? Yeah, we need to append it. Yeah, sorry about that. We need to append the neighbor. Okay, looks good. Let's submit. And that passes our test cases, and we have a 60-day streak. Yeah, please like and subscribe, and see you on the next one. Bye.